Okay, now that we've nailed down multiplying rational expressions, we're going to move on to dividing rational expressions. And just like the other operations, this is going to work the same way for rational expressions as it did for fractions. So if we remember back to years past, when we divide a fraction by a fraction, hopefully you all remember that we're going to do a process, maybe you had different names for it, where we're going to take the first fraction and keep it the same, change the middle operation to multiplication, and then flip the second fraction upside down. You probably have called this different things like keep, change, flip, or multiply by the reciprocal, or switch it and multiply, or whatever cutesy phrase we have, but it all equates to the same thing. We keep the same first fraction and instead multiply by the reciprocal of the second fraction. And when we do this, we end up getting 12 over 10, making sure we reduce. You can see a common factor of 2. When we take a common factor of 2 out, we divide 12 by 2, get 6. Divide 10 by 2, get 5. 6 over 5 is our reduced fraction. Okay, but the key piece here was to keep that first fraction, change that second, or change that operation, and then flip that second fraction. So you'll hear me refer to it quite a bit as doing keep, change, flip. So to divide rational expressions, we're going to do the exact same thing. We're going to keep the first fraction, change the operation to multiplication, and then flip the second fraction. So you'll hear me refer a lot to KCF. Has nothing to do with fried chicken, so be careful. It's KCF. You might also hear me say, or you might be thinking, multiply by the reciprocal. Exact same thing, exact same meaning. Okay. So to divide rational expressions, we're going to do the same thing. We introduce letters, x's, y's, and so forth. Nothing changes. We keep the first fraction, change the operation to multiplication, and flip the second fraction. So let's practice KCF, keep, change, flip, multiply by the reciprocal. Okay. So here in example 4, if I look at that, I have a fraction divided by b minus 1. First thing I want to recognize is, of course, that b minus 1 is really b minus 1 over 1. So when I go to execute keep, change, flip, I'm really going to have, if I keep the first fraction, I have 2b minus 2 over 5. I change the operation in the middle to multiplication. And when I flip the second fraction, I'm flipping b minus 1 over 1, so I'll have 1 over b minus 1. Now, you'll notice I'm multiplying rational expressions, so we'll use the same skills we just were practicing in the last few exercises. So I'm going to multiply the numerators, multiply the denominators, but I know I need my final answers to be in simplest form, so I'm going to go ahead and factor where I can right now. And if I do that, I take out the common factor in the top left, I'll see real quick there's a common factor of b minus 1 that can get canceled. So I do that, I cancel out common factors. Now I can just multiply straight across the top. 2 times 1 is 2. And straight across the bottom, 5 times, the only thing left here is a 1. So I have 2 over 1 is my final product, or just 2. Okay. Sorry, I'm crazy. In the bottom, 5 times 1 is 5. My final answer is 2 over 5. 2/5. But the process is all the same there. When we divide fractions, we keep the first, change the operation of multiplication, and flip, i.e. we multiply by the reciprocal. Same exact thing for rational expressions. So let's just go ahead and practice a couple more. I would encourage you to do keep, change, flip. Then as you're multiplying, you'll see that you can factor and cancel. So do keep, change, flip, then factor and cancel. That's my suggestion. But you can do it different ways potentially. So if I do the keep, change, flip, I'm going to actually work top down here on this problem and see how that plays out. Like I said, there's different ways that you could express your work here. or show the order of your process. I'm going to go ahead and do keep, change, flip first. So I'll just write that out first here. I'm going to do keep, change, flip. So I keep the first one exactly the same. Change the operation of multiplication and flip the second fraction. Now I'm multiplying rational expressions, so I'm going to do my process where I multiply the numerators and denominators, but it's going to be much, much, much simpler if I factor and cancel first. So I'm going to factor. If I factor the top left, I have a plus 2 times a minus 5. That still is over 5a. In the bottom right, I have a common factor of a, leaving a minus 5, and then 15 in the top right stays the same. And now I would look to see to cancel any common factors that I can. So hopefully it's obvious to me that there's a common factor of a minus 5 here. So I can cancel out the a minus 5s. And then also there's a common factor of 5. That leaves 3 behind here. And it's tempting to cancel maybe these a's or somehow try to cancel these a's, but none of those a's can actually cancel each other. So as I go across the top from left to right, I have a plus 2 times 3, or I could just write it as 3 times a plus 2 all over. In the bottom I have a times a, and that's a squared. Again, it's tempting to cancel some of these a's, but nothing cancels. This a is a term. It cannot cancel with the denominator at all. So there's our final expression. If you wanted to multiply the 3 through, you can call it 3a plus 6 over a squared. Either of these answers would receive full credit. One is not better than the other. So there we go. When we multiply, we factor and cancel and then multiply. If we're dividing, we have to do keep, change, flip first. Let's look at one more that can be kind of confusing. If you remember back to PEMDAS, we said that order of operations says evaluate parentheses first, then exponents, and then to do multiplication and division at the same time from left to right. So as we look at an example like this, sorry, this is a little bit hard to see there, that 6 is on top of it. As we look at an example like this, we need to be careful with our order of operations. Multiplication and division need to be done at the same time from left to right, which means that I'm going to do this division first. So I'm going to divide these two expressions first, then multiply that result by 3 over a. So be careful here. So if I'm doing this division here first, inside of the parentheses, I would do keep, change, flip. So I have 3a over a plus 3. Change that to multiplication. And then flip the second fraction, so I'd have 2a plus 6 over 5a. And then when I'm done with that, that result gets multiplied by 3 over a. So this first two get multiplied together, then I multiply by 3 over a. Although now that it's all multiplication, the associative property kicks in and those parentheses aren't necessary. But what's important is to recognize that you're only going to flip the fraction that immediately follows the division sign. So be really careful when you have multiplication and division mixed in together. But now that we have all multiplication, we can follow our process from above. Essentially, we just want to factor and cancel, just like we did yesterday for simplifying. Just factor and cancel, and then multiply whatever's left over. So I have 3 times a over a plus 3 from the first fraction. The second fraction, I have a common factor of 2, leaving a binomial a plus 3. That's all over 5a. And then I'm left with a 3 over a. And now I'm going to scan across, canceling out any common factors. I can see, hopefully, that there's a common factor of a that can cancel. Notice I'm only canceling one of these two factors from the denominator. There are two separate factors. It's really a times a. So those two separate factors, I can only cancel one at a time. Since there's only one a in the numerator, I'll only cancel one a from the denominator. Hopefully I also see a common factor of a plus 3. And now I'll multiply my results. What's left, the factors that are left, multiply them together. 3 times 2 times 3 in the numerator is 18. In the denominator, all I have is a 5 and an a. So I have 5a as my denominator. And there is my result. So multiplying, dividing rational expressions works the same way as any of our other fraction rules that we've had in the past. For multiplying, we want to just factor and cancel just like yesterday. If we're dividing, we're going to do keep, change, flip first, and then follow the same rules for multiplying rational expressions. So anyhow, make sure you're ready for a factoring quiz tomorrow. And you'll get plenty of time to practice these multiplying and dividing operations, and then I'll be back sometime soon next week.